Welcome to the next video all about solving linear inequalities. Linear inequalities are very similar to linear equalities, except for a few differences. Three main differences. Let's talk about the first one. The first main difference between linear equations and linear inequalities is the symbol that we use. For equations, we always use an equal sign. For inequalities, we use a symbol like this that signifies either greater than, like this one, greater than or equal to, or less than or equal to. So that's the first difference. Let's talk about the next two differences as we go through a few examples. First example, we've got x plus 7 is less than or equal to 12. So as with linear equations, we're looking for x that satisfies this inequality that will make the left side now less than or equal to the right side. So let's go ahead and solve this. Just like working with equalities, we want to group like terms. So we want all of our x terms on the left, and we want all of our non-x terms, our number terms, on the right. So we've got that 12. We want to move the 7 over. And again, just like with equalities, when we move something over the inequality to the left or to the right, it changes sign. So that plus 7 will become a minus 7. So we're looking at x is less than or equal to 12 minus 7 makes 5. So here's the second main difference, the solution. Remember that the solution to a linear equality was a single x value, like x equals 5. When we're dealing with inequalities, now our solution is a range of values. If you look at what this is telling you that any number that's less than or equal to 5 will satisfy the equation that you started with. So 5 would work, 4 would work, 3 would work, minus 50,000 would work. So how we like to represent these solutions is with a number line. So if I draw myself a little number line, 2, 3, 4, 5, 6, and over here into the negative numbers, then I could represent this solution by saying 5 would work, and everything less than 5 would work. So I can draw a little arrow pointing in the direction that I want to go. From 5, I want all numbers less than 5. So instead of a single solution, we have a whole range of solutions that works here. Let's look at the next example. Again, starting with the way we work with equalities, we're going to do the brackets first. So moving the 2 inside to these terms, 2 times x is 2x, minus 2 times 1 is less than 3x minus 4. Then we group our x terms on the left. So we have a 2x. This moves over. It becomes a minus 3x. We've got our minus 4. This moves over and becomes a plus 2. And on the left-hand side, there are 2 x's minus 3 x's. Leaves us with minus 1x is less than minus 4 plus 2, negative 2. Now, at this stage, what we want to do, what we learned from the equalities video, was that we need to divide each side by what's in front of our x, so negative 1. But here's the third main difference when it comes to inequalities. Whenever we multiply or divide by a negative number, only a negative, we don't have to do this for a positive, we have to flip the inequality sign at that stage. So here, what we want to do is divide both sides by negative 1. So on this side we've got x. On the right side we have minus 2 over minus 1. The negatives cancel. 2 divided by 1 is just 2. But instead of saying less than as it was above, we want to, at this stage when we divide by the negative, flip the inequality. We do that because dividing or multiplying by a negative number flips that arrow in our number line to the other direction. So if this is now our final answer, we could make the number line There's 0, 1, 2, 3, minus 1, minus 2. And what we're looking for now is all numbers greater than 2. Note here that we don't include 2 in the solution. If I plugged in 2, my original would not be satisfied. Only numbers bigger than 2. But that doesn't mean we start from 3. That means we start from 2.1 or 2.01, very, very close to 2. So how we signify that is with an open circle instead of a closed circle like we used in our last slide. And we want everything that's bigger than 2. So in this direction here. So 2 things to remember from this example. First thing is, if we divide or multiply both sides by a negative, we have to remember to flip that inequality. And then, depending on whether we've got a less than, a greater than, or a less than or equal to, greater than or equal to, we're either going to use an open circle or a closed circle. For this next example, we start out with fractions. So we want to clear those fractions first. We only have one, denominator 2, so we'll multiply by 2. Not inside the brackets, that 2 will get carried through, but every piece needs to get multiplied by 2. So these 2's cancel, leaving us with 1. We don't have to write the 1, we just have 6 minus 2x on the left there. It's greater than or equal to 2 times 4 is 8, minus 2x. Collecting like terms, on the left we have a minus 2x, and when this moves over it becomes a plus 2x. On the right we have an 8, and when this 6 moves over it becomes a minus 6. So what we're looking at here is 0x is greater than or equal to 2. In other words, 0 is greater than or equal to 2. This statement is false. 0 is not greater than or equal to 2. And we've seen a situation similar to this with equalities. Within inequalities, the same thing rings true. When we end up with something like this, where we have a 0 coefficient in front of our x, it means that our equation was not linear to begin with, and it means that no x would satisfy that inequality. No matter what I plug in, it wouldn't work. Next example, similar but just slightly different. So again, let's multiply everything by 2. These terms cancel, leaving us with 6 minus 2x is greater than or equal to 6 minus 2x. Grouping like terms, we'll have minus 2x plus 2x is greater than or equal to 6 minus 6. Now we're looking at 0x is greater than or equal to 0. Or in other words, 0 is greater than or equal to 0. Which, because that equal sign is in there, this is a true statement. 0 is greater than or equal to 0. It's equal to 0. So this is a situation where any x would have satisfied the original equation, but because there was that 0 in front of the x, we know again that that original equation was not linear. So, 3 things to remember when we're working with inequalities. The first thing is that instead of an equality, we have an inequality symbol. The second thing is that instead of having a single correct answer, we now have a range of correct answers that we can represent on a number line. And the last thing is the little trick that when we divide or multiply both sides by a negative number, we must remember to flip that inequality. That's solving linear inequalities. See you for the next video.